Ramanujan was an Indian mathematician who made extraordinary contributions to mathematical analysis. His works involved number theory, the infinite series, and continued fractions. His application in mathematics was also notable, such as his estimation of pi. I'll be talking about this slightly later. His genius slowly gained recognition, and in 1913 he began a correspondence with the British mathematician Godfrey H. Hardy that led to a special scholarship from the University of Madras and a grant from Trinity College, Cambridge. So, what is a magic square? Well, a magic box is simply a square that's divided into smaller squares, particularly 3 by 3. Each smaller square contains a number such that the figures in each vertical, horizontal and diagonal row add up to the same value. In this case, the value was 15. So, what is a Ramanujan magic box? In a Ramanujan magic box, the rows, columns and diagonals add up to the same number. This is also true for any other patterns, such as opposite sides or corners. In this case, the sum of all rows, diagonals and columns was equal to 139, as well as any other patterns. It is also no coincidence that Ramanujan's birthday was on the 22nd of December, 1887. So, can we make our own Ramanujan magic square? So what we did is we listed the possible permutations, and we made the date, month and year correspond to the 4 letters A, B, C and D. We found this. If we reverse this with D, C, B, A for the second row, where the first row is A, B, C, D, we swap the first and second term, as well as the third and fourth term for the third row, group terms 1 and 2 and terms 3 and 4, and swap the two groups for row 4. The same principle of the Ramanujan box can be found. A, B, C, D, D, C, B, A, B, A, D, C, C, D, A, B. So let's test it. King's College was founded on the 14th of August, 1892. 1408, 1892. Let's substitute these values in. Now, we were looking if this follows the Ramanujan principle. Well, we can see that it clearly does, as the numbers 18, 92, 08 and 14 turn up in all 3 positions. This is similar for all of the others. So, how can you take this one step further? We took this one step further and observed Ramanujan's magic square. We noticed that the numbers were not random, but were 4 different series in ascending order. However, they still added up to form the sum of A plus B plus C plus D. This theoretically still works. So, is that all he did? What else did he do? Well, one example is the number of partitions of a positive integer n, the famous Hardy-Ramanujan asymptotic formula. For the partition problem, the formula has been used in statistical physics and is also used, first by Niels Bohr, to calculate quantum partition functions of an atomic nuclei. Ramanujan-type formula, due to the Chudovsky brothers, used to break a world cut for computing the most digits of pi.